Have you ever just stopped and wondered about the rhythm of our world? The simple, reliable dance that our planet does every single day, every single year. Well, today, we're diving into the two huge movements of the Earth that literally shape our lives. I mean, it's the most basic thing we experience, right? The sun comes up, the sun goes down. But what's actually happening up there to cause that constant, predictable switch from light to dark? And then you've got the bigger cycle, the long, warm days of summer that slowly, surely give way to the cold, short days of winter. Why does that happen? Well, the answers to both of these huge questions are all about two key motions of our planet. All right, first up, let's tackle the motion we feel every single day, that daily spin that gives us our 24-hour cycle. So to really get this, we've got to be crystal clear on two words that sound kind of similar but are totally different: rotation and revolution. Let's kick things off with rotation. Rotation is pretty much exactly what it sounds like. It's the Earth spinning on itself, kind of like a basketball on a finger. It spins around this imaginary line that goes right through the North and South poles, called an axis. This is the planet's daily spin. And here's the direct result of that spin. You see, the Earth is a sphere, so the sun can only light up one half of it at any given time. The side facing the sun, that's daytime. The side facing away, that's nighttime. And that moving line between day and night actually has a really cool name. It's called the circle of illumination. So one full spin takes, you guessed it, about 24 hours. And get this, if you're standing on the equator, that spin means you're moving at over 1,600 kilometers per hour. We call that full 24-hour spin an Earth day, and it's the foundation of how we measure our days. It's so easy to just take this whole daily spin for granted. But let's do a little thought experiment. What if it just stopped? What would our world even look like if the Earth didn't rotate? Well, the result would be absolutely catastrophic. One half of the planet would be stuck in a permanent, scorching hot day, while the other half would be a frozen, dark wasteland. Life as we know it, well, it just wouldn't be possible. So that daily spin isn't just about day and night. It's what makes our planet livable. Okay, so rotation gives us our day. But what about our year? For that, we need to zoom out and look at the Earth's second massive motion. Its epic, year-long journey. So at the same time the Earth is spinning, it's also speeding through space on a huge trip around the sun. This movement is called revolution. It follows a set path called an orbit that's not a perfect circle but more of a slight oval, or an ellipse. Now this whole trip takes 365.25 days, but our calendars only have 365 days, right? So what happens to that extra quarter of a day, those 6 extra hours that pile up year after year? The solution is actually really clever: the leap year. For 3 years, we kind of just ignore those 6 extra hours. But every 4 years, they add up to a full 24 hours. So we bundle all that extra time into one extra day, February 29th, and that keeps our calendar perfectly in sync with the Earth's journey. Pretty neat, huh? Okay, so rotation gets us day and night, and revolution gets us the year. But that leads to the biggest mystery of all. How does that yearly trip give us the seasons? Now, here's a really common idea. Summer happens when we're closer to the sun, and winter when we're farther away. It sounds like it makes sense, but it's totally wrong. Yeah, the answer is a big no. In fact, for those of us in the northern hemisphere, the Earth is actually farthest from the sun during our summer. The real secret to the seasons isn't about distance at all. It's because our planet is tilted. That imaginary line the Earth spins on, the axis, it's not perfectly straight up and down. It's tilted. Relative to the flat path it takes around the sun, it makes an angle of 66.5 degrees. And that little tilt, well, that changes everything. And here's the crucial part. That tilt is always pointing in the same direction in space as the Earth makes its year-long journey. This means that for part of the year, one hemisphere is tilted toward the sun, getting more direct, concentrated sunlight. Hello, summer. And for the other part of the year, it's tilted away from the sun, getting weaker, more spread out sunlight. And that's what creates our seasons. This tilted journey gives us 4 key moments in the year, which are like landmarks that officially signal the start of a new season. Around June 21st, the northern hemisphere is tilted most directly at the sun. That's the summer solstice, our longest day of the year. But at that exact same time, the southern hemisphere is tilted away, so they're having their winter solstice. The exact opposite happens around December 22nd. And then you have the equinoxes in March and September. On those days, neither hemisphere is tilted toward the sun, so the sun's light hits the equator directly, and day and night are almost exactly equal everywhere on the planet. You know what's amazing? This is not new information. More than 1,500 years ago, an ancient Indian astronomer named Aryabhata figured it out, stating that the Earth is round and rotates on its own axis. It just goes to show you how long we've been looking to the stars to understand our world. So let's wrap this all up. It's really just two simple constant motions, working together perfectly to create the world we know. So the two main takeaways here are pretty straightforward. First, the Earth's 24-hour spin, its rotation, is what gives us day and night. And second, its 365-day journey around the sun, its revolution, plus that all-important tilt, is what gives us our seasons. It's really a beautiful, delicate dance, isn't it? That daily spin and that tilted yearly journey are responsible for the most basic rhythms of our lives. It really makes you stop and think, what would this world be like without that perfect, fragile balance?